Mathematics Form 3, Chapter 8, Loci in 2 dimensions, 8.1 Locus.
Yes.
Okay. What do you understand about loci? So a little introduction about loci. Locus is how to pronounce this locus, and this is loci. In the picture on the right, a piece of colored sticker is pasted on the tire of a bicycle. Here, pink color. What is the shape generated by the sticker when the bicycle is pedaled? Okay. When we pedal this, yeah, we know the back tire here will also rotate, like this. Since we paste the sticker there, um, if the tire rotate speed enough, so how will we see the shape that generate from that coming from this pin here? Can you guess? Can you guess what is the shape that been shaped by this object here, by this color pink?
Hexagon.
Hexagon? Is it so? Hexagon? Huh? Hexagon? What do you mean? Can you imagine? It's going to make a circle. This pin here, we're going to see it's going to like draw a circle, circle line here, full with all pin here, because it rotate along with the bicycle. Okay.
Cikgu,
Yeah.
tu PEDALLED tu apa?
Ni
Ha.
pedal it, we try to push a
Kayu.
force by our leg, yalah, itu in itu is a translation, try to translate in English, okay. We pedal, we mean we push this pedal, so it in order to make this tire on the back rotate, okay. The work that we do lah, okay, is what we call pedal. Where are we? The shape formed by the sticker is a circle. Okay, it's going to look like circle lah. It start with this, only this sticker on this side only at one point here like this. But if it keep rotate in a circle, so we'll see that it's like this sticker here is all around this circle. Okay, this is what the shape it's going to be, as shown in the diagram on the right here. Does this shape comply with certain conditions? Okay. The picture below shows a ball being kicked by a football player. The movement of a point on the ball yields a curve. So here it is. Before the ball is, Wafa has joined. Who is Wafa? Saya ramai pula ni. Najmi, tak pernah nampak Najmi. Okay, let's continue. Okay, again, where is it? So before the ball is here, the ball is here, and wait, I got something to show to you. Oh, here it is, a piece of paper. Can you see this transparent plastic here?
Yes.
Yes.
Come on. So, you know what? I'm going to do something on the transparent plastic here to do some animation lah. Okay, I'm going to place the plastic upon this picture. So here I'm going to mark the pink sticker there, and then what? And then I am going to rotate the sticker there that I just marked. But before that, to ensure the rotation doesn't move but only rotate on the center, so I need to stick the needle on the center. So you see, now I can rotate this. Oh, wait a minute, I need to cut off a little. So again, so here it is. Can you see?
Yes.
So if we rotate this high speed enough, we can see that it's going to trace all the color in a circle. Okay, I believe you got the idea. And so does this football player here. If we mark this ball here, okay, and because we know that this ball is moved in a curved direction like this, it is like it's coming from a center, from one center. We don't know where the center is, but the idea is like this. Okay, see, let's say this is the center, so the ball begin here, and once it being kicked by the player, so the ball goes like this, in a what way, in what direction, in what shape, in a curve, in a curve shape. Okay, start from this. Okay, the leg no longer touch the ball, so the ball will go straight, not go like this, rotate all around him like this. No, okay, it rotate just because it follow the movement of the leg. Okay, because of the movement of the leg is curved, so this is why the motion of the ball is also in curve like this. And what happened here, after the leg no longer touch this ball, so the ball will keep moving straight forward, up there. Okay. Now here we have another example. All of these examples is in order to begin the introduction about loci. Soon you'll know what loci is. The picture on the right shows a rocket being launched. The movement of a point on the rocket will produce a straight line. So you see on this rocket they mark with a blue dot there. Can you see that one? So we know this rocket going to go straight upward. So how do we going to see this blue? How this blue going to shape out the sky? It's going to look like a straight line, a straight line blue here. If we connect all the blue, the trace of the blue, we're going to see it. The trace going to be, the shape going to be in a straight line, correct?
Yes.
So a simple idea to begin with. So now we come to the definition of locus. What is a locus? A locus is a trace or trajectory. Do you know trace? Do you know trace?
Yes.
Trace mean we kind of follow the path. We try to detect the way or the path of the motion. That is the trace, or trajectory formed by a set of points. A set of points in a plane or three-dimensional space that satisfies certain conditions. Okay. Maybe we'll come back to this later. For now, maybe you have no complete idea what this means. Soon you'll know. Maybe we'll come back to this definition later. So here we got a little activity for you to do. The aim is to identify two-dimensional loci in daily life situations. Two-dimensional. Do you understand two-dimensional, three-dimensional? So here we have a situation A, throwing a ball into the net. So this ball is red in color. If we make the trace of this ball, so we're going to see the red curved line, right? Like this. How about this situation B? A durian falling from a tree. Durian falling from a tree. Okay.
Straight
So we're going
line.
to see. It's like if we connected all the green points while it going down here, we can see it's formed a straight line here from up there until here. See, okay, it landing very fast, so you're going to see the curve green like this, okay. And here is the moving tip of the wiper. Oh, okay. At the end of this wiper, so we'll see it's going to be curved, correct? Going to be curved.
Yes.
Okay. Now what can we make a generalization from this activity? The shapes of two-dimensional loci can be seen in the form of straight line, arcs, and curves. Okay, the shape of two-dimensional loci can be seen in the form of this, either straight line, arcs, or curve. Okay. Example 1. Point C is drawn on a blade of revolving fan as shown in the diagram. Elaborate and sketch the locus of point C. Here we got a fan. We put a mark on the end of the what? What do we call this? Propeller. Okay. So once we switch on this fan, we're going to see how do we going to see this?
Circle.
We're going to see it form a circle.
Yes.
So okay, this dot here is going to fill all the circle here. A good idea to explain what loci is. Maybe I can show you something. Let's do some activity with this. Can you see this? You got this at home? Okay. Let me see if I can do something about this. If I can do something about this. So you see, I got this a plasticine, and then what? I'm going to put it there. Put some mark on the what? On the transparent paper, like that. Now I'm going to stick this on this. So you can see it rotate. Can we have a better view? Yeah. Can you see the rotation?
Yes.
Not a good view, Not a good view. Wait, can I? Okay. A little experiment for you. Do you find this interesting? Not so
Yes.
interesting. Okay. Now, back to this. Okay, so the what? Okay, what is the? How to elaborate the locus of point C? So we say this locus is a circle. Okay, so point C here has become has formed a circle. Okay, has formed a circle, and we say this locus is a circle. So now, do you understand what locus is? The locus is a trace of some movement. Okay, now we have mind test 8.1a. A ball centered at C, rolling along an inclined plane. So here we have a ball. We mark point C at the middle there. Can you see? Now, once we release this ball, it's going to fall and rotate all along this plane. So how will it look like? How will it look like?
Straight line.
In a straight line. You need to focus on this small point in the middle there. Yeah, of course this ball is going to rotate like this, but the center remain at the same middle, correct? Okay, if we connect all the middle point here, we can see it form a straight line only. It form a straight line. So the locus of point C here is how to say is straight line. Okay, B. Point C on a swinging pendulum. Oh yeah, we need to sketch this because the question asks for also for sketch. Where is it? Where is my pencil? Okay. So once they ask you to sketch, you need to sketch the trace like this. Okay, start from where the mark. Here it is, the locus of point C. Now B, point C on a swinging pendulum, swinging. So the idea is, okay, this is going to be point C. I'm going to illustrate this for you, so you have a better imagination. Now it swing like this. This swing here coming from a center. It's coming from a center. It must be a center for something to swing like this. So the trace is what shape of this trace?
Curve.
If you connect all the points here, it's going to be curve. Okay, good, very good. So we're going to what? To draw a curve. How to draw the curve? How to draw a curve? You can use the ruler to make a curve. let me get you to better position. Okay, here it is. By a little assist from the ruler, we can bend the ruler like this, so you will have a nice drawing of curve like this. Uish, tak answer. Boleh lah. Okay, you see the curve line? This is what we call the locus for point C. So the locus is a trace. Can we go back to the definition? What is a locus? It's a trace, a set of points. Okay, we got many points actually. Point of C here. Okay, kind of like that, and we kind of connected all the points. So that's this one. Okay, kind of connected all these points, and we'll see what shape it's going to be. See, point C on a spinning yo-yo. So here it is. We mark C there, and we know this yo-yo going to go up and down, and this C will follow up and down, and at last we see the locus of this C going to be a straight line like this. Correct? Okay.
Yes.
Yes.
There is a little spot on the shoes. So this kid here slide along this plane. So how do we see this C here from up there until below there? We're going to see also in a straight line. Okay, like this. As this kid slide down like that. Okay. So here we have straight line, here we have curve, here we have straight line, here we have curve, here we have circle. Other than that,
Arc.
arc is also a curve, correct?
Yes.
A curve. Arcs. What is the difference between arcs and curve?
At the end.
Okay, they almost. Is it this arc coming from one center? Is it this curve is not coming from any center? Okay, never mind. But the idea is both is not straight line lah. Both is curve. Okay, so here it is. We get straight line, arcs, and curve. So is it the locus? All the locus that we will have only either straight line, curve, or arc. Let's continue our journey to confirm that. To state and sketch the locus of point on a coconut falling from a tree. Yeah,
Straight
we
line.
can imagine it directly straight line. A moving car on a straight road.
Straight
Moving car,
line.
straight line, horizontal straight line. See a leaping frog. A leaping frog.
Curve.
Okay, I'm going to be curve because the frog jump like this.
Yes.
Okay, so the curve it is the locus. Example 2. The diagram on the right shows a pole MN. Where is it? Okay, here pole MN. Do you know a pole? It is like a pillar Do you know pillar? Pillar, a pole, a road
No.
a road where the thing is rotated, a road. Here is a pole, okay, here is a pole where we attach anything on it. So this pole here, a drill here, going to rotate in a middle. So whatever that attached to it also going to rotate. You got the idea? The pole is kind of a center of rotation. A rod where it rotate on the center like this. So this is what we call a pole. So this MN here are going to be at the center lah, the center of rotation like this. A rectangular board. Okay, do you know rectangular? Rectangular, just a rectangular like this, rectangular. Okay, rectangular board. PQRS is attached to the pole. Rectangular is a polygon with 4 sides, where PQRS is movable. So this can be movable. Where is the push? So it is like this lah, rectangular. Okay, a rectangular, what is this? Eraser. We attach it there on the rod. If the side PQ is rotated 360 degree around MN, what is the three-dimensional shape form? Can you imagine that? So in order to do that, let's do some activity that use this. So this is going to be pole MN. So let's attach a rectangular piece of paper, and then we're going to rotate with a drill that I got. Do you want to see the activity?
Yes.
Very good. So how do we supposed to do that? For that reason, I'm going to need a piece of paper, a hard one. Can we do with this? Let's try this out. A piece of paper. Okay. How to attach this? Any idea? How to attach this? Can I do like this? Let's fill something inside so it hold better. Yeah. So here it is. Does this look similar to this? Now let's rotate them. Okay, here it is. A very cool gadget for you to have, a drill. You'll find it useful in many ways. So now we're going to rotate this. Okay, see also on upside here. Okay, the view is not so good, But I think you got the idea lah, Okay, never mind that. So, what is the idea?
Dia jadi silinder.
Yes, it's what it's supposed to look like. So once we rotate this, it's supposed to look like a cylinder. It form a cylinder. It form a 3D. This is what meant by three-dimensional. And so below here, okay. Okay, it rotate all the way 360 degree like this. It start from this only two-dimensional, 2D only, but once it rotate in where the MN is a pole, so it's going to, if we put this point of Q here, it's going to trace like this, right? The circle up there. So this make things look circle up there, and this also point P here also going to rotate, okay, from the center S here. So what make this look circle on the under here? So every point here also going to rotate on the same pole here, every point here. So this is why at last we connected all the points and it looked like 3D shape. That is cylinder. Okay. So what is the question? What is the three-dimensional shape form? The shape form when the side PQ is rotated 360 degree around pole MN is a straight cylinder. Yes, it is. It is like if we put the color on this. Put the color. Let's say we put the color red on this plane here, P to Q here, okay, like this. And then we rotate it, okay. So this is when we will have the cylinder all the way around. Okay, I believe you can imagine that. Example 3. The diagram on the right shows a pole MN. Okay, again MN, a circular board PQR is attached to the pole where PQR is movable. If PQR is rotated 360 degrees around MN, what is the three-dimensional shape form? Okay, so this rectangle here we turn to what? Let's turn this to what? Semicircular board. Huh? Where is my? Okay, here it is. Are you ready? Are you okay, all of you? Do you get bored?
Yeah.
No, huh? Never get bored. Oh wow, a good one. See? Let's attach. How to attach this? Any idea? Wait, I got this. You see? I got this tape. Unbelievable, isn't it? Unbelievable. How can I got so many things here? Huh? Ta-da! Simple one, huh? Like this. I'm going to cut this excess tape here. So here it is. If I mark this, let's mark this so we'll see it clearly all the way around here. Okay, do you see what I see? Now where is this special tool here? Now I am ready now. Do you ready? Let's give it some rotation, 360 degree. Do you see what I see? Maybe not so good in camera, you know.
Yes,
But
tapi
outside here,
sekat-sekat sikit tadi.
because the camera got the frequency, you know, got a frequency. Okay. So what you see on your screen is not a actual frequency. The higher the frequency, the better the camera, the better you will see on your screen. Okay. But yalah, Still it is a very much help for you to imagine, to help your imagination. How does this semi-circular board here going to look like if we rotate it 360 degree? It's going to form what shape? It's going to form a sphere, 3D shape, a sphere.
Sphere.
The shape formed when the semi-circular board is rotated 360 degree around pole M and need to mention that one too is a sphere. Ta-da! Okay. Oh, how to make this shape? What shape is this? It look like a glass. A drink glass, right? With upper side is wider than the lower side. So, where does this 3D shape here coming from? What 2D shape that form this 3D shape? If we have a pole in the middle there, it's coming. It's coming from this. Just like this. So if we rotate this on TS pole, it's going to look like this.
Itu akan jadi frustum.
Yes, it is. Okay. See, it resemble like this. So can you imagine? Can you form 3D that coming from this 2D? If we
Piramid.
rotate in the center here, okay. This is going to look like
Piramid.
pyramid. Not like pyramid. Like a cone. Like a cone. Like this. Okay, like a cone. Okay. And what about this?
Kun terbalik.
Kun terbalik.
Cone terbalik. Tak tahu hak mana terbalik, hak mana tak terbalik. Terbalik atas, terbalik bawah. Ikutlah. Ni.
Sphere.
Okay, going to become. Is it sphere? No. This is not sphere. Because it's not complete sphere. It's going to be
Semi-sphere.
Semi-sphere. Good. Semi-sphere. If we have this another one, then we're going to put it up there to become full complete sphere. And then this one you already know. Okay, so what is the question? Sketch the three-dimensional loci when the two-dimensional shaded shapes are rotated 360 degree around pole ST. This the way they say it, you need to memorize them. Soon you'll be using the same way to explain things. Okay. Any question? Any doubt? Any doubt? No.
No.
Got no problem.
Cikgu, kalau
Kalau
3-dimensional tu kan, dia tak boleh jadi piramid kan. Sebab dia kan rotate kan. So dia tak boleh jadi piramid kan.
dia yang mana?
Yang tu.
Yang ni?
Ha.
Kenapa tak kamu terbayangkan
Jadi
ada
piramid.
tak 2D yang boleh jadi piramid macam ni kan? Saat cikgu tunjuk. Kan? Kamu punya idea macam tu kan? Apakah 2D when we rotate around pole, we can have this shape, correct?
Yes.
You know what, kid? Remember, what is the possible shape only that we can have of doing the locus? What is the possible shape only that we will have when doing the locus? Is only this straight line, either straight line, either arcs, either curves. So there is no way, there is no way. So we see here, this is not straight line, this is not circle, this is not curve, this is rectangle. So there is no rectangle here. Means that for any 2D shape, then we rotate it, there is no way we can have this shape, because this shape here is not a locus. It's not a locus.
Yes.
So this is why we can never ever get this shape. We can only get this shape. There is a cone, not a pyramid. Cone here is okay because here is a circle. The effect of locus. Here also circle, circle, circle. So you see, whatever it is, it's going to form a circle only. Circle, circle. Okay, circle. So maybe soon you're going to face this question, which asks you that either this or that 3D shape coming from locus. Then you know, if the shape is not if the 3D shape is not circle, then it is not a locus. Okay, it is not the doing of the locus lah. Let's continue. 8.2 loci in 2 dimensions. What is the locus of points? What is the locus of points that are of constant distance from a fixed point? What is the locus of points that are of constant distance from a fixed point? So here some activity to begin with. Now a simple one for you. You can do it. Even right now you can do it. Now we have this point O here. Can you see? And this point O here is fixed. Fixed means it cannot move. Fixed point. It cannot move. Okay, because they're going to be the other point going to rotate all around this fixed point here with some also fixed distance or constant distance. Do you know constant? Constant similar to also fixed. Constant, fixed distance mean the length doesn't change. What happened? The length doesn't change. Okay. Example, if it began 5 centimeter, whatever happened, the motion between this point here and this point, fixed point here, this point going to be far from this point with 5 centimeter. So let me ask you this. If this point is U and this point is fixed point, the condition is you need to, whatever move that you make, you can only be far with this point here only 5 centimeter. Now let me ask you, where can you go? Where can you go? So the distance between you and this point is remain 5 centimeter, doesn't change. Can you go this way? Can you go this way?
Yes.
No.
No, cannot, because if you go this way, the length will be changed.
Lebih 5
5
centimeter.
centimeter, 6 centimeter, 7 centimeter. You cannot go this way. Can you go this way? This way?
No.
No, cannot.
No.
Why?
The length will be shortened.
Because the condition, you need to stay 5 centimeter only from this fixed point here. You go this way, you become closer to this point, which is not 5 centimeter anymore. It lower 4 centimeter, 3 centimeter. So how can you go? Where can you go? Sorry, where can you go? So that
Right or left?
the distance between you and this still preserve this value 5 centimeter.
Curve.
You can only go around here, around this, which the length still preserve 5 centimeter. And you know what? This trace here, this way here, will make up the will make up the circle. Okay, at last form a circle just like this. Okay, so I'm going to stick a needle there, so it won't move except rotate all around. So this is you, the red spot here. Whatever happen, the condition is you must always distance of 5 centimeter from fixed point. So all that you can do is only rotate this. Okay, can you see? Okay. Macam cerita apa, lembu nak korban tu kan, tambat lembu tu kat pokok dia tak boleh pergi mana kan, dia boleh pergi sejauh mana tali tu di ni radius ni saja dia boleh pergi. Okay. So you know what, if we mark every time we passing through the trace here, we can, let's say we put a mark on almost each point hit there. Okay, so we'll have this mark here, these points here, and guess what, if we connect all the points here, we're going to look the shape of circle, correct? So now come to conclusion. Points marked at the same distance from a fixed point O forms a circle. Okay, that is the idea. Let's read this. The locus of a point that is equidistant. Do you know equidistant?
Yes.
Okay, equal in distance. The distance is equal. They combine become equidistant. The locus of a point that is equidistant from a fixed point is a circle centered at that fixed point. A circle centered at that fixed point. Okay, so soon if they give you this one fixed point, then you can guess already what shape that you're going to have from the fixed point given. That only one thing that The only one thing that we can have from fixed point is a circle lah. Okay, a circle. Okay, not the other shape, but only a circle being formed if we have a something, a locus from a one fixed point. Where is it? Okay, what we got next activity, to construct locus of points that are of constant distance from a fixed point. So we have this activity given only one point, fixed point here, and given how far the distance, and we can make the trace lah. Okay, we can make the trace, we can have the locus, and then we'll see what the shape it's going to be. A point that always moves at the same distance from a fixed point forms a circle. Okay, another same activity, same conclusion lah. Okay, example 4, construct a locus of point P which is always 3 cm from, this is the condition that given. They need to give this condition lah, instead of point, fixed point. They need to give this information, that is how, what is the distance, 3 cm from a fixed point Q, fixed point O. So first you're going to mark point O, and then you're going to set your compass to given value, constant distance, that is 3 cm. Then you're going to construct a circle out of this radius 3 cm. Okay, this is how to answer, how to construct a locus. What is the locus of points? Points. This time, not one point. This time, got so many points, because plural here. So what is the locus of points that are equidistant from two fixed points? Oh wow, something new. If given to us two fixed points, before only one, but now we got two fixed points. So here, followed by a little activity to answer that. So let's say we have two fixed point here, P, and point Q here. The distance in between is 8 cm. Now let me ask you this: how do you going to, if you in the middle here between P and Q, somebody asks you to, wherever you go, make sure that the distance between you and these 2 points, fixed point here, P and Q, must remain the same. Now, how, what shape that, what trace that you can go? What trace that you can go?
Curve.
How do you going to move?
Curve.
Curve.
Is it curve? Okay, let's say curve. You mean, okay, you start here, curve to this P, Is it go this way?
No.
If yes, of course, if you stay here, okay, here we got 4 centimeter. Here we got also 4 centimeter. Okay, before you begin with same distance between P, U and P and U and Q. Okay, now, is it your idea you're going to move like this so you see the distance between U and P is 4 centimeter. Okay, correct. But it is not equidistant anymore between U and point of Q. It's going to be far, more than 4 centimeter. Okay, the idea is how do you going to move away from P and Q so your distance is from U and point P and Q is equidistant. How you going to move? Between
Circle.
U and P, not between U and P. Not this. You don't need to preserve this 4 centimeter. It can be varies. Only you. The only thing that you need to care is that you need to be fair. You must be the distance between U and this P is the same as U to this Q. So what the locus going to look like?
Semicircle.
Semicircle? I cannot imagine that one. Is it you're going to go this way? Is it this way? To form a semicircle like this?
Macam tu.
Okay, like this. Now let's say you are here. So let me ask you, how many distance between you and this P?
Panjang sikit. Lebih.
Lebih daripada 4. Okay, berapa?
8.
Ha? 8. 4 jugalah ni. Kan lebih kurang lah 4. Tapi daripada kamu kepada point Q ni tak sama dengan kamu ke point P. Tak adil lah. Is it you don't understand the question?
Macam mana? Tak faham. Sekali lagi dulu.
Aduh. Bahasa Melayu lah. Macam mana? Ke mana kamu boleh pergi? Ke mana kamu boleh pergi? Kalau kamu mula tengah ni, ke mana kamu boleh bergerak? Supaya ke mana sahaja kamu bergerak akan memelihara jarak antara kamu dengan titik P sama dengan jarak antara kamu dengan titik Q. Buatlah apa pun asalkan jarak antara kamu sama dengan titik P dengan jarak antara kamu dengan titik Q adalah sama. P ke kamu sama dengan panjang P ke kamu ke Q. Jadi kamu nak boleh bergerak ke mana? Syaratnya itu saja. Apa yang locus, shape of locus going to look like?
Straight line.
Straight line sajalah. Straight line sajalah. Kamu nak boleh pergi mana lagi? Straight line ni. Kan? Tak percaya, Mai. Kamu duduk sini, jarak P ke kamu dengan kamu ke Q sama kan?
Ya.
Sama. Tapi kalau kamu duduk sini?
Sama.
Ni jarak ni. Kan sama ni. Sama. Tengok, kan masih mematuhi condition tu. Tapi kamu duduk titik ni.
Sama.
Kan sama. Sama lah juga ni jarak. Sentiasa memelihara jarak yang sama antara kamu ke dua titik ni. Betul tak?
Betul.
Jadi kamu boleh bergerak macam ini sahajalah.
Straight.
Asalkan sama, membahagi sama antara, last kali kalau kamu kumpulkan semua titik ni, bawah ni pun samalah kan, boleh pergi ke bawah ni. Ni samalah. Last kali kalau kamu kumpulkan semua titik ni, titik-titik ni, kamu connect all of them. This is when you get this trace. This trace here is what we call loci, a locus, locus or loci. Nah, the locus that been formed by
Straight line.
this condition, that is always equidistant from two fixed points is this straight line. Boleh dah faham? Madiha, okay? Itu saja pun, simple. How come you don't get this idea? How come you don't have this idea? Cannot think of this idea? Okay. Itulah dia tu. Ini mendapat titik kan ni. Okay. Which these points here divide by two equidistant length, P to Q, two equidistant. This is what we call equidistant, equidistant length. Equidistant. Simple, So, coming to conclusion, the location of the intersecting marks that are equidistant from fixed points P and Q form a straight line through the midpoint of PQ. Okay, in general, the locus of a point that is equidistant from two fixed points is the perpendicular bisector of the line connecting the two fixed points. Do you understand this one? Perpendicular bisector.
No.
Isn't this line is perpendicular to this line PQ?
Yes.
Perpendicular, you
Dia dapat 90.
understand it? It's 90 degree. Okay, it's 90 degree among them. That is the idea. So the idea is next time, if you find this kind of question given to you two fixed point, and then they ask you to find locus, you already can imagine how it's going to, what will you have, the form of the shape of the locus. It's going to be a straight line, which the locus of the straight line is perpendicular bisector to this line connected to between P and point of Q. Okay. Yeah, before we learn, given to us only one fixed point, correct? And the locus that we must be able to imagine is only a circle with equidistant radius. But if given two fixed point, the thing that should come up quickly on your mind is we're going to have a straight line of locus. Okay. Now we got next activity to construct locus of points that are equidistant from two fixed points, or the other example, but same concept lah. The same concept. Here we got 2 points point P and R. So the same question, now construct the locus. Construct the locus of this point P and R. You're going to have the same straight line here, which divide by two equidistant length between point P and R. Okay, connects all those points is what we have this straight line, which is perpendicular bisector to. Okay. Oh yeah, why perpendicular here means 90 degree. Bisector here means what? Bisector here. Bisector. They combine both term here. Bisector here means the length, the area is the same size between left and right. Is what meant by bisector. Okay, the length or the area here is the same size. The same size. The locus that is equidistant from two fixed points A and B is a straight line perpendicular to the straight line AB, and it passes through the midpoint of AB. Yes, correct. So, oh, wait a minute, I got something. Okay, where are we? So do you accept this? Do you accept this statement? Got any problem? Any
No.
objection? No, Okay. How do you construct the locus of points that are equidistant from two fixed points? Or the same one, another. Do you know how to construct a straight line, the locus from this M and N here, which is perpendicular and also bisector, which divide this M and N equally? Do you understand me? You cannot, you know what? You cannot just place your ruler and estimate it like this, to the right, to the left like this, and just estimate the distance to be equal. Then you put a line here, which is a very wrong way. Okay, like what I'm doing here. How do you know that this line is first perpendicular, and how do you know that this line is divide to equidistant or bisector? How do you know?
Use kaedah ni.
You cannot. We cannot we cannot estimate. We need to do this in proper way. You know the way already. Actually, we use it so many times. When you add form 1, form 2, so many times. How we got to points here, how do we divide it by the same bisector? Is by using this compass, correct? By using this compass, we can make the straight line by perpendicular bisector to this both fixed point. So you're going to, I'm going to quick show to you lah. So you're going to place a needle. Okay, I'm going to mark up and down like that. Okay, mark some up and down, and then this is, be careful not to change the length of the compass. You're going to do the same process on the other points. Also mark up and down the curve. This is when you got 2 points up and down. 2 points where the intersection of the arcs, and you're going to place your ruler. Okay, passing through both points that you just acquired, like that. Okay, and believe it or not, this line is the real line, which is perpendicular to line MN, and also divided this area the same size, the same length. Okay, any problem? No,
No.
So we have come to the end of our class. We shall meet again. Do lots of exercise. You can begin your answer your workbook, PBD workbook. Any question, you can message me as usual. Until we meet again. Assalamualaikum.
Thank you, Cikgu.
Thank you, Cikgu.
Okay.
Thank you, Cikgu.
Yeah.